This is exercise 7 in chapter 2. It's found on page 53. It says, suppose that a sample space has 5 equally likely experimental outcomes, E1, E2, E3, E4, and E5. They're all equally likely to occur. Let A equals E1, E2, B is equal E3, E4, and C is equal E2, E3, and E5. Find the probability of A, the probability of B, and the probability of C. Well, what is the probability of A? A, if you notice, there are 2 events, E1 and E2, and there's a total of 5 events. So what is the probability that the 2 out of 5 occurs? It's 2 over 5. What is the probability of B? B has 3, E3, and E4. Again, it's 2 out of 5. What is the probability of C? 1, 2, 3. 2, 3, and 5 out of 5 events total. It's 3 over 5. This is also 0.4, 0.4, and 0.6. Question B. Find the probability of A union B. And then it says, are A and B mutually exclusive? Are they mutually exclusive? Well, we have to write the formula for the union of A and B. Probability of the union of A and B. A union B probability is equal to the probability of A plus probability of B minus the probability of A intersection B. That is the general formula for A union B. What is the probability of A union B then? Well, the probability of A, we already know that is 2 over 5. Probability of B is 2 over 5 too. The probability of A intersection B is the probability that A intersection B occurs. These are the elements that are found in A and in B. Well, if you look at A is E1 and E2, and B is E3 and E4, they do not have elements in common, so the intersection of these 2 events is just an empty set, and the probability of that to occur is just simply 0. So 2 over 5 plus 2 over 5 is 4 over 5. So are they mutually exclusive? Yes, they are. Because are they mutually exclusive? And the answer is yes. Why? Because the intersection of the 2 is equal to 0. They have no intersection, which is the definition of mutually exclusive. Now, question C is find the complement of C of A, or A superscript C, the complement of C, and then the probability of AC and the probability of CC. Well, what is the event of AC? The items that are not in A, they are outside A. Well, A has E1 and E2, so the complement of A would be all the elements that are not in A. It'll be that, E3, E4, and E5. And what would be CC? Well, it has the elements that are not in C. C is E2, E3, and E5. So the elements that are not in C are E1 and E4, because these are 2, 3, and 5, the remaining E's. So what is the probability of AC? The probability of AC is 3 out of 5. The probability of CC, or the complement of C, is 2 out of 5. Now we're going to have to move down on the page. Question D. Find A union B complement and the probability of A union B complement. Well, again, we have to define what they are. We can copy again A, which is E1 and E2, and B complement. What is B complement? The elements that are not in B. Since B here is E3 and E4, consists of elements E3 and E4, then B complement is E1, E2, E3 and E4 are present, so we just need E5 here. What is A union BC? A union BC is defined as A plus B minus plus BC, I'm sorry, minus A intersection BC, which is the same expression that we see here, except that we don't have the probability. This is the definition of the union of two sets. Okay, so it'll be the elements that are in A plus the elements that are in B minus the elements that are in the intersection of A and BC. I meant to say BC. Okay. So what is A union B complement? Well, in terms of elements, A, it'll be E1 and E2 plus the elements in the complement of B, E1, E2, and E5, minus the elements that are in the intersection of the two. If you notice, E1 and E2 are also in the intersection of the two sets. Again, I think I got out a little bit of the screen. E1, E2 plus E1, E2, E5 minus E1, E2. Okay. The idea is that we always subtract, we have to subtract the elements that are in common, because if we don't subtract those elements, then they're going to be repeated. So what is this equal to? Well, E1 and E2, they're added, they're repeated, but then they're subtracted. So we just have to put E1, E2 once. And then we have E5. And that's it. These are the elements, as the definition of union is, or indicates, the elements that are in A, or in B, or in both. So these are the elements that are in A, or in B, or in BC, I'm sorry, or in both A and BC. Now, what is the probability that A union B complement occurs? Well, it's 3 elements here, so it'll be 3 out of 5. And finally, question E. Well, let me put question E here on my next page. Question E is asking for probability of B union C. Well, we just write again the formula for the union, probability of the union, probability of B plus probability of C minus probability of B intersection C. Probability of B is E3 and E4. We already wrote this in the previous page. This is 2 out of 5 plus probability of C, 1, 2, 3 elements, 3 out of 5 minus, we're going to do this at once. What is the probability of B intersection C? Well, the probability of B intersection C is, if we look at B and C, what do they have in common? Well, this one is E3 and E4, and this one is E2, E3, E5. So the one element they have in common is E3. So we need to subtract the probability that E3 occurs, which is 1 out of 5. So this is equal to 2 over 5 plus 3 over 5, that is 5 over 5, minus 1 over 5. And that should be 4 over 5, or 80%. So that is the solution to this problem.